So 4 over 3 here multiplied by pi. So we come here and insert our pi. And then multiplied by radius cubed. Multiplied by radius cubed. So this is how you are able now to get the volume of the sphere. For the surface area, we had already said. So whatever you require here is the most important thing. There's only one important thing here in a sphere, and that one is called the radius. So the same case applies for the hemisphere. The same case applies for the hemisphere. But for the hemisphere, it is going to be different. So for the hemisphere, let's say we are using the hemisphere with the, we can use the same or the, just a different radius here. So let's say the same hemisphere has a radius of 7 centimeters. Let's say in this hemisphere here, radius is equals to 7 centimeters. Okay. Now, a hemisphere is a half of a sphere. So how are you going to find its volume? And I will bring you to this person here who had drawn this diagram here. Here, I'll just put it below here. So it's the same as saying 4 over 2. Let me come here. I'll show you how I'm going to start this formula. Fraction here. So this one here. Yes. And then here, I insert another formula. Yes. So 4 over 2 over 2 pi. Someone is mic is on, which is not the right thing. 4 pi r squared. 4 pi r squared. Yes, 4 over 2 pi r squared. But this because now we are talking about a hemisphere, you have to define the all of that over 2. I was just trying to see whether I can be able to type it properly. So whatever I'm saying is 4 over 2, it is 4 pi. Let me start pi. 4 pi r squared. This one is the area, surface area of a whole sphere, not a half of a sphere, a whole sphere. Remember, a hemisphere is half of a sphere. So after you get the answer, whatever you get as your answer, because it's a hemisphere, you divide by 2. You divide by 2. And that's why you can see in this formula here, you are told that the surface area is the curved surface area. Actually, whatever we are talking about, just look at the difference between the sphere and the hemisphere. As you can see, the sphere is the outer part. But hemisphere, there's a place that you can see. There's a top. There's either a circular top. Yeah. Look at this shape here. This shape here, this circular part here, it is a circular top. So a hemisphere is made of a curved surface area, just like the sphere. But unlike the sphere now, because it is cut, there is a part which is here it is a top circle, and here it is a bottom circle. So when you're finding the surface area of a hemisphere, you are going to find 2 things. Number 1, the curved surface area. The curved surface area, you get the formula from the formula of a sphere, and that is what you're going to divide by 2. So if you divide 4 pi r squared by 2, is where now you can see the answer now becomes 2 pi r. Let me come here. 2 pi r squared, 2 pi r squared. 2 pi r squared. So I come here and I see this. Oh, no, I'm supposed to put this. Yes, 2 pi r squared. Because you have divided, when you divide 4 by 2, definitely you're going to get 2. So this is the curved surface area now. This is a part for the curved surface area. Curved surface area. Now, what about the top? Now, remember we said the top is either a circular. As you can see the shape here, the bottom here is a circle. I'll bring you to this one here. As you can see here, the top is circular. So the curved surface area is what we have said, 4 pi r squared divided by 2. And then we have now the top. So the top is made by a circle. So how do you find the area of a circle? So the top of a hemisphere, top of a hemisphere is equals to circular, which is a circle. So how do you find the area of a circle? The area of a circle is found by pi r squared. So you'll come here and you insert your pi, and then you see r, and then you see squared. Pi r squared. So you come here home and then you make it squared. You make it squared there. So yeah, very good. So you can see now the curved surface area is 2 pi r squared, and the top, which is of a hemisphere, which is a circle, found by pi r squared. So that means the two of them, you have to add them together. So it is like you are saying you are having 2 pi r squared. Let me just copy them here instead of typing them. I will copy this. And then I say plus pi r squared. To copy pi r squared here. I'm hoping that where you are, you have your items to note. So you have a pen and somewhere to write, and then you can solve this. So it is 2 pi r squared plus pi r squared. So I'll come and explain why the examiner said this. Why is saying 2 pi r h? Remember I said h and radius are the same. So instead of having 2 pi r squared, he is having us 2 times radius times h. And I said radius and h are the same. So instead of having 2 pi r h, in the case that we are having 2 pi r squared, because radius and h are the same thing. The height and the radius, in this case, I told you they are the same. Then you can see here, the area of this bottom circle here is found by pi r squared. So when you add that, when you add 2 pi r squared plus pi r squared, you are going to get So you are going to get this one as 3 pi r squared. 3 pi r squared. 3 pi r squared. Why? Because 2 pi r squared and pi r squared, you can see we have pi r squared here. Pi r squared is the same as 1 pi r squared, okay? That's why we are getting 3 pi r squared. So the top of a hemisphere is either a circular that you find by using the formula pi r squared here that I've highlighted here in yellow. Yes. And then the curved surface area, you use the formula of a sphere, that is 4 pi r squared. And then because hemi, a half, you divide by 2. So you get 2 pi r squared. But most of the people, they use that formula and they don't remember that the top is either a circle. Yeah, remember the top is a circle. So you have to include that circular part. Yeah, this part here. Hii part iko circular hapa hivi. This part here is the one that we are going to talk about. Let me show you that part using a shape. I don't know whether I'm going to get a better shape here. Yes. Hii shape unaona iko hapa hii. hii shape kutoka hapa mpaka hapa. This is a circle. That is one that we are calling circular. That shape we are talking about here. So hii shape tumeweka hapa, tunasema this shape here, the top here is circular. And then you find circular by saying pi r squared. This other shape here is a curved surface area. Curved surface area, just like you know a sphere, just as you know, the sphere is made just of a curved surface area. It's like a ball, so it's only the outer part. But when you cut it now, you are able to have the small part that we have seen. So that is how you can be able to find the surface area of a hemisphere. So the bottom, the circular part is found by pi r squared. The curved surface area is found by 4 pi r squared divided by 2, where you get the answer is 2 pi r squared. So if you add that mathematically, definitely it is like 3 pi r squared. Remember, when you go to the exam, don't just put the formula. You have to explain to the examiner why you are doing that. So volume now, volume of a hemisphere. The volume of a hemisphere is very simple. So it's going to be 4. Remember, we say it's 4 over 3 pi r cubed. This is the formula of a sphere now. Pi r cubed by r cubed. 4 over 3 pi r cubed. Okay. Now this 4 over 3, you are going to divide it. Because it's a hemisphere, again, this answer you're going to divide it by 2. So the whole of this, the whole of that you're going to divide it by 2. You divide it by 2. This 4 over 3, maybe I can write it better, so if you're able to see it in a better way. So you can now have 4 over 3. So 4 over 3 pi r cubed. The whole of that answer, you now divide by 2. And then you get your answer here in, for example, if it was in centimeters, you find your answer in cubic units, cubic centimeters. This one here would have been in centimeters squared because it is area. So don't confuse area and don't confuse surface area and the volume. So that is how you find the volume of a hemisphere. So ladies, here, that is, I can see most of you are ladies. Gentlemen, I don't know they are joined. So that is how we can be able to get that. So I don't know what is wrong with Billy. He keeps on joining, and at the end of the day, he's not successful at all. So I don't know what's wrong with him. And that one happens for people who are joining us for the very first time. Wanakuwa na mashida zingine. Yeah. Okay, kwa tasoti hiyo. Now remember I said I have a call, so you have to keep on excusing me. So that is how you are able to find the surface area, the volume of a sphere and a hemisphere. And that one will bring us to the end of that topic. That one will bring us to the end of that topic. So I encourage you to note your question somewhere. And then on the chat button, yeah, on your screen, you can see when you come here, is a place where you chat. Okay, you can come here and chat. You can come here and write a message for everyone or to me. If you want to write to me, if I want to write to someone, I just come and choose here. So you come here and choose whoever you want to write to. Okay. If you want to write to everyone, you just write it to everyone. So I'll see that, or you can raise your hand, and then later I will now come and answer your question. So I wanted us to start another topic that I know we have not covered with the January class. Remember the September class, you're just doing your revision. So I'm sure that you are enjoying or you are benefiting a lot from this. So I want to take you straight to something called the gradients and the equation of straight line. This is a topic that I want to take you through. I don't think we have covered this topic with you, and it's a topic that is heavily examined in your questions. So I would like to come and talk about that. Now, so a gradient and equation of straight lines. Today I want us to cover this topic because we have just been, I think I've been teaching very slowly and we might not be able to cover whatever we are supposed to cover within the short time. So here, this a gradient. So a technician is to climb the top of a wall 3 meters high for repair work. This is shown in the figure below. So technician ni mtu ni fundi ambaye anaenda either kuinstall something, yeah, anataka you want to climb this wall here. So he is going to use a ladder. So he is going to get from either A to B. You can see A is below here. A is ground level, and the B we have B is the top of the building here, top of the wall, or from C to A. Yeah. Now these two people, if you put your ladder at A, you see you see there's a distance that you want to cover. Okay, this is the distance you want to cover. This is a vertical distance that you want to cover here. I can show you that one using that shape. The vertical distance that you want to cover is here. That's the vertical distance that you want to cover. Color is not very appropriate for that setting. So there's the distance that you want to cover, or I can make it dark. And I give it some more weight. So there's the distance that this fundi, this technician wants to cover, this distance. But because you cannot climb directly, that's why it's now going to the option of taking a ladder. So you can take the ladder at A, or you can take the ladder at C. You can see that it's going to be different. For example, if your ladder is at A, this is the horizontal distance. You can see this horizontal distance here. That's the horizontal distance here. Let me give it some more weight. That's the horizontal distance that you're going to cover here. If you pick the ladder at C, if you put your ladder, if you place your ladder at C, this is the distance that you are going to cover, which is quite different. So you can see that the horizontal displacement, or the distance when you place your ladder at C, is different from when you place your ladder at A. Now, if I was pushing, if this was something I'm rolling here, for example, let's say this is a lorry, instead of being this one being a wall, it's a lorry, where I want to pack some containers, some water containers here. So I want to roll them. So I'm rolling them, just rolling them here. At A, the distance is going to be shorter. At C, the distance is going to be longer. But at C, I use less effort than at A. So at A, the distance is less, okay? But I'm going to use more effort. At C, the distance is longer, but I'm going to use less effort than I use at A. If I want to use even more little effort, what I can do is I can do this. This here. Ukitaka kutumia effort kidogo, distance nayo inaongezeka. This displacement here, the distance here now becomes bigger. Yeah, the distance now becomes big. So yeah, that's what happens. I know most of you maybe have tried that. Yes. So what we are going to say now is we are talking about two distances. This distance here is the distance where the ladder is placed. But to achieve that distance where the ladder is placed, we are going to be using two very important distances. And we have said one is called the vertical distance. One is the vertical distance. Okay. One is the vertical distance. That's the vertical distance that I'm displaying here. Yes. And the second one is this other distance here, which we are calling the horizontal distance. The horizontal distance. The horizontal distance. So we are covering this distance here and that distance here to be able. This is what we are following. But you are here. You are standing here. You are standing this distance from the wall, and then you are going to cover this distance, again to the top of the wall. So this is what we call gradient. So gradient is what we are going to cover here when you are climbing your ladder. And we can see gradient covers two distances, the vertical distance, and we can see this one also covers the horizontal distance. So it is, the gradient is actually a ratio. I'll come here and something else here. So the gradient, not that. Don't want to share. See. Let me find somewhere to write here. So I can simply say gradient is equals to, it's a gradient is found by a quotient. Is a quotient relationship. What does that mean? What is a quotient relationship? A quotient relationship means something is being divided with another. So I come here and say a quotient relationship is this. So I can simply say here, come here and say gradient, which I'm going to call a gradient, is equals to, this one here is the vertical distance over the horizontal distance. So whatever you're seeing here, me talking about the quotient relationship, a quotient relationship is this, whatever I'm saying here. It is, we have something being divided by the other. And in this case, to find the gradient, we are dividing the vertical distance and the horizontal distance. The vertical distance and the horizontal distance. So let us come back to our original example and see how we can achieve that. So we are being told here the distance from the feet of the ladders are 2 meters and 2.5 meters. Obviously 2 meters ni hii ndogo. That is from A to the bottom of the wall is where we have 2 meters. And from C to the bottom of the wall is where we have 2.5 meters. Okay. And then we are told, what else have we been told? The corresponding vertical distance is 1.5 meters, 1.5 meters. So you are being told that the vertical distance, this distance here, the vertical distance here is 1.5 meters or 1.5 meters. The vertical distance here from C ni mpaka hapo, from C we are told is 2.5 meters, and from A we are told is 2 meters. So we can find the gradient of the person who was studying at, who climbed the ladder at A. Who climbed the ladder at A. So we are going to come here and then we are going to solve it. So gradient at A is going to be found by a vertical distance over horizontal distance. The vertical distance you have been told is 1.5 meters. Okay, that one I think is very clear to all of us. 1.5. 1.5 is 1.5. Yes, and then from A it is 2 meters. From A it is 2 meters. Yes, let me come here. Gradient at B, is it at B or at C? At C. It's going to be, let me confirm whether it's at C. Yeah, this point here is C. Gradient is at C. Are we doing the right thing? Let me read this question again because I don't want to make it. Oh, the technician is to climb at the top of a wall. The wall is 3 meters high. I'm sorry. The wall is 3 meters high. So the wall is 3 meters high. So I'll have to change that. Yes. So this is not 1.5. This is not 1.5. This one is 3 meters. And so at C, we also insert our formula here. So at C, we have 2.5. The distance below is 2.5. So the top, the top of the wall is the same, but here it is. This one is 2.5 meters. So you find the gradient at the two areas. So we are remaining with 40 minutes in our video, in our second video. Yes, so 3 divided by 2, I know the answer is 1.5, which is 1.5 meters. The dimensions were given in meters. Yes, 3 divided by 2.5, you can very well do that one at home. Let's see. 3 divided 2.5. No, this is 3 divided 2.5, and the answer is 1.2. So the answer is 1.2 meters here. That is the gradient. 1.2 meters. 1.2 meters. So this is how we can be able to find, or we can be able to calculate the gradient. Let's go very quickly go to our second example. In the other 8 minutes, we should have introduced something new. So I'm going to take you to something here. I'm going to refer as a Cartesian plane. And just give me a moment to do something. Just a moment. Then I can just a moment here. Just a moment. Just a moment. Okay, so we are here now. So we are here. We are remaining 6 minutes in this video. So whatever I've done here, whatever I've downloaded here, this one is called a Cartesian plane. Hmm? So a Cartesian plane is made up of the x-axis and the y-axis. Let me make it a smaller. It's made of the y-axis and the x-axis. So the vertical axis is the one that's called the y-axis. So you can see this one is the vertical axis. Vertical is that. So that's the vertical distance, okay? So the vertical axis is the one that we call, we give the name of the y-axis. So the whole of this So the whole of this, you can see here, let me just show you. The whole of this, whatever you can see here, this arrow here, showing top and bottom, is what we call the Y axis. And then the horizontal axis, I'll make it bigger. And then the horizontal axis is what is now called the X axis. So here we are going to have a number of, if you want to name your Cartesian plane, this here, just a moment, just a moment. What's wrong with this one? So let me share this document here. Yes, so I can be able to edit it properly here. So the Cartesian plane is where we have the X and the Y axis. So this axis here, the horizontal axis here, as you can see me putting it, this axis that is here, this one here horizontally, this one is what you call the Y axis. Now this, you can see here, this one is 1. So this going from 0 here, the point 0 here, this point here at 0 is a very, very important point. And I want to show you what this one is called. So the points where we have there, that point is called the origin. It's called the origin. And the origin is where we start reading all our measurements. The origin. The coordinates for the origin, any reading on the Cartesian plane is called a coordinate. Any reading you are reading here on the Cartesian plane is called a coordinate. So you have seen the vertical axis is called the x-axis. On the right is where we have the positive units of the x-axis. And this one, we have the negative units of the x-axis. On the vertical axis, on top here, that is not towards north from the origin, is where we have the positive displacement on the y-axis. And here we have negative displacement on the y-axis. So the origin, you can read that coordinate. So any place on the coordinates. So any place on this Cartesian plane, any point is called a coordinate, and that coordinate can be read by saying this. So the first reading here is called a reading on the x-axis, and then you put a comma, and then you have a reading on the y-axis. So when you are reading this coordinate here, you start by reading it on the x-axis, and then you now continue reading it on the y-axis. Now, for example, the origin, the coordinate for origin here is the origin, there is no distance I'm moving on the x-axis or the y-axis. I'm just staying there. Also on the y-axis, I'm not moving anywhere. So I'm here. So it is, this coordinate is read as 0, 0. And what 0, 0 means, it is 0 units on the y-axis and 0 units on 0 units on the x-axis and 0 units on the y-axis. But I can come here and read this point here. Let me read that point there. Let me format this arrow so that it can be seen properly. I want to give it more width. Yes. I think that color is not bad. So I want to read this coordinate here exactly where I have. Now, when you are reading a coordinate, you start by reading the displacement on the x-axis. What distance from the origin are you moving on the x-axis? The whole of this.